Okay, I give you another example of the displacement in the case of one dimension. Here you have the x-axis, okay, and y-axis, the central point O. Here we have a position. I repeat, we have a position, not an object. A position A. Here we have a position B, and to the left we have the position C. I give you the distance between O and A equal 20, between A and B, for example, equal 50, and between O and C equal 30 meter, meter, meter. First of all, I ask you to find the displacement between A and B. Between A and B, as you know, equal the final position vector B minus the initial position vector A. Let us draw geometrically this position vector. So RA, the position vector, comes from O to A, and RB, it's a vector from O to B. This is RB, and this is R. The red color is RA. Okay, you see here we don't have y components, just x components. Equal R equal xb plus yb minus xa plus ya. We don't have y components here. We have just x component. The x of A is directed to the right, so it's in the direction of plus I. The, the x of B also is directed to the right, so it's in the positive I direction. Equal xb magnitude times the direction. It's in the positive direction. The same for xa magnitude in the direction of plus I. Equal xb equal 20 plus 50 equal 70 I minus xa equal 20. Always you come from the origin to the point. The origin to the point. This is the x distance. Equal 20 I. So it's 70 minus 20 equal 50 I meter. Okay, this is a value. You see here we have positive value sign. It means we have a positive displacement. It's important to know, to precise if you have a positive or negative displacement. So the displacement here between A and B is positive. We say it's a positive displacement. Okay, if you want to show the displacement geometrically, it begins from the initial point to the final point. This is the displacement delta R A B. It's directed in the positive direction. It's positive. Now I want to give an example in the case of the negative direction. Okay, find the displacement between A and C. As you know, equal R final minus R initial. Let's draw this. Oops. Okay, here we can draw the position vector at the point C from the origin to the point. It's RC. Okay, so equal XC plus YC minus XA plus YA equal, we don't have Y components because we are working only one dimension, in the X direction or in the Y direction. XC as magnitude XC in the direction of negative direction minus I. So minus I minus XA here XC and XA in absolute value. XA in the positive direction. So in the positive direction. Equal XC equal 30. I minus XA equal 20. I equal minus 50 IM. You see here negative, so we say delta R AC is negative displacement. Geometrically, the displacement is a vector between the origin to the final point. Excuse me, from the initial point to the final point. Initially, it was at A, and the final point is at C. So this is delta R delta R AC. The last one, what is the difference between the distance and the displacement? Here we have an example. Initially we have an object at the point O, pass like this and to the final point here. The distance equal the total distance passed by the object equal 70 plus 30, it's equal 100. But the displacement equal only the vector between the initial point and the final point. It's independent to the path. So it's from here to here. It's 40. So you have a difference between these two quantities. An example, if we have initial point A and one object do this path and the final point is the same A. Here the total distance we can say equal 800 meter. This is the distance, the real distance. But the displacement equal to zero because it's the distance between the initial point and the final point. Here, these 2 points are the same. Thank you.